Hello everyone and welcome back to another tutorial and welcome to Sumit Institute. So in this tutorial we are going to look at a code on abdominal abnormalities classification using deep learning. So what we are going to do here is we are going to have a data set and with different classes with n number of classes, and on the basis of that we are given CT scans of different diseases in the stomach. So we called it abnormalities, and we have to classify which of them are for example, if one is cancer and one is kidney stone, so we have to classify whether it is a kidney stone or a cancer by training the data set of 9 different classes or n different classes through a neural network that we are going to create. So we are going to do the code on Colab and using Python. So without any wastage of time, let's go, and first of all we'll be looking at the data set that we are going to use. So we are going to use this data set computer CT of the abdomen. So this is a Kaggle open source data set that you can always download. That's just 422 MBs, and if we'll look into the data set, we'll find that it has a folder named file, and inside that again a folder is files, and which contains n number of classes, whether we should that the number of n is 9. So in 9 different classes with these are the classes you can see, and also a CT abdomen.csv which locates all the files, and each file contains different images that are in the form of JPEG and DCM. So we are going to use we are going to use these classes and these images to train our neural network. And yes, I'll be providing this open source data set, Kaggle data set, in the description box, so you can also code that. And always the code is always available in the description. You can click on the link and see the code, and it will be provided to you for free. Also, if you have any questions, you can always comment in the comment section. So let's go to Colab and let's see what we have done. So first of all, I created a file named abdomen.py, so a very simple file, and I have imported some modules. Most of them are not useful, but I just wrote on ChatGPT that give me a list of machine learning and deep learning modules. So I imported all of them. Actually they are not as important as it is, so we just need few modules, right? After that, what we did is we are given the data set, and we are then defining the data set location. So data dictionary is equal to pathlib.path. So we have imported that module also. Okay, yes, we have imported this PIL. Okay, so pathlib.path, and we are given the path of the files, and in the train also we are given the path of the files. So after that, what we are doing is dataset path train is equals to os.layers dictionary, then print dataset path train and print number. So what we are doing, we as we are defining this data dictionary, so what we are doing here is we want to see how many classes are there. So we are just analyzing the data right now. So we want to see that how many classes are there in this particular data set. So as we have done this, we got all the names like vertebral compression, fracture, ultralysis, and formation of adrenal gland, kidney development, and blah blah. So after that, we want to print the number of classes because we are not going to count 1 2 3 4. So to make our work easy, we did length dataset part train, and number of classes is 9. That's it. And then we go down and we find that image count train in length and this. Okay, so number of train data sets. So we want to see how many training data sets are there. It's showing 0, so that's good. Then so now the main thing is here we are defining batch size, image height, and image width, because we don't want to always define what is batch size, what is image height. So at first we are defining it, and we'll be using it again and again after we write the code. I hope you understood that. Then we are just pre-processing all our data, and we're defining pre-processing all the data, classify, and then like making a good files for the data. We are just pre-processing it, and for training data, train that's and yes, validation split is 0.2, that's 20%, and then image height, as we have given here, 224 image width. We are just pre-processing all of that here. Okay, so found 144 files belonging to 9 classes that we did here, and okay, seems good. And then we go down and we find we are just creating our model right now. So to create our model, we have to import tensorflow.keras.layers, and then we are using inception ResNet layer. Okay, so what we are doing here, we are using inception ResNet. So to do that, we are importing the inception ResNet from TensorFlow, and then that's it. Number of classes we are defining 38, and then base model is equals to, so what is our base model? That is equals to inception ResNet v2. So I hope you know what is inception ResNet, so I will not waste out my time and like explain this. If you want me to explain it, please do comment below. I will also make a video on that, not an issue. So include top, false, input shape, image height, that is 224, image width 224, and this 3, that is RGB. Okay, and then okay, image net. So what we are doing is we are importing a predefined weights, that is image net, open source, and then freeze the layers of the pre-trained network. So we are freezing some layers that we don't require for our classification, so we are doing that here. And then model is equals to always, like always we do, model is equals to sequential, then model dot add layers dot experimental pre-processing rescaling. So we are rescaling our like actually what we are doing, in simple words I can say that we are actually pre-processing our data, right? We are pre-processing our data by given input shape, what it should be, like if it is irregular shape, if it is triangular or any other shape, and it's not like compatible for our pre-processing. If we do not do the pre-processing, then the classification cannot be that accurate with so much accuracy, and also it would not be that suitable, right? So to do that, we have to pre-process it, and if we are doing it here, so then add the inception ResNet v to base model. We are adding the b to base model. So I've written this code very simply, so if I provide it in description also, you can always read the comments, and you can like this comments, and you can always like know what I'm doing in this each and every line of this code. So it can also be used by you for your final year projects in your universities or colleges. Okay, then after creating our model, what we are doing is we are summarizing the model. Okay, so we summarized it, and I didn't got it that well. So what I want to do is I want to plot it. So to plot it, we write this code, you can see here. So I just plot the model with rescaling input layer, that is okay. After input, then rescaling layer, we are inputting our inception ResNet layer, and then global average pooling, then dense, and last option the dense 38. So it is a very good neural network for the classification, and it is also very useful for you to write the research paper that you are working on. So it is very good. So model.compile, at last model.compile, we are doing optimizer, we are choosing Adam optimizer, then loss we are choosing sparse categorical cross entropy, and then matrices always accuracy, as we want to see the accuracy, and then we are doing the model.fit. So what it didn't took me so much time actually. It just took me 479 for the first epoch, and after that we did 10 epochs. So with a decrease in loss and with an increase in accuracy, we got 99% accuracy with a validation accuracy of 97%. That's very good for now, and we are very good to classify our what we see the data set, right? So it is 99% accuracy we got here. Then after doing this, like it didn't took me that much time, but after doing this, what I did is performance equals to model.evaluate, and we are evaluating our model for the best accuracy it can give. So it was, the best accuracy was 97%. It is very good accuracy, I guess. So I want to say a thing here, that if you're writing a research paper, so a very short research paper or a documentation, so what you can do is you should show this. Okay, so you should always show what in the first step you are doing, then the second step, then third step, what you are doing in each and every step of each and every epoch, and how the accuracy is changing. You should always plot the graph, and you should always show that. Okay, so it looks like very fine and neat work like you are doing. The presentations should be very good if you are showing something in a research paper or in a projects. So that was the thing I want to say. So okay, and then after this what we are doing is labels is equals to train data dot class names. So okay, labels, we are defining labels for image batch, label batch, and okay. So what we want to do here is, see, we are just defining labels. So what we can do, the actual label, so we can print the actual label from labels that we have defined, that is actual labels abdominal aorta dilation, that is AAD, and then what is the predicted label should be like NP. So what our predictions comes is in our prediction, the output of our prediction is in a form of array. So what we have to do, we have to convert that array into percentage, and that should be a percentage, or it defines what in which class it belongs to, right? So the classification was fine. So what I wanted to do here is, I didn't want it always to print in just one image, right? So what I did, I will show that also. So first of all, as I was telling, you should plot each and every epoch and accuracy, showing that. So this is how you plot each and every epoch and accuracy. Like it was 10, so you have done this. If it's 100, then you should the plot should be much bigger, right? Like it should be either this should be like 10, right? And yeah, so this looks good actually. It's a very good way of presenting your work in a research paper or in any project you're doing. Then epoch and loss, how the loss is decreasing with epoch, with an increase in epoch the loss is decreasing. First the loss was 1.25, that is very high in the first epoch, but it came lower and lower and came like below, like it came almost to zero, right? Below zero, not below zero, almost zero, because it was 0.75 something, so it was almost zero. So that is a very good achievement for us. And yes, after this what we are doing is from TensorFlow import expand dims and new access. So yeah, so what I wanted to do, I wanted to plot each and every, like from some classes I wanted to plot this you can see, yeah, this is it. Like so it should all, this image is like I wanted to show what was the actual, what was the predicted, and how much was the confidence rate for it. It was 86% confidence that it is that ADA whatever, and then actual was lever formation and predicted was lever formation. That was the confidence rate was 99%. That's like great. And here it gave a confidence rate of 100%, right? And that is abdominal aorta dilation and abdominal aorta dilation, that is 100% with an 100% accuracy. That's good. And again it gave 100% accuracy and lever formation. That's good. The only mistake it did was any mistake it did, yeah, here it did a mistake, the dilation of aorta, it gave a 50% accuracy. See, the confidence rate was very low, 50%, so it was not sure what it is. Sometimes it can make a mistake, but that mistake is just 3%. In a 97%, it is just 3%, like the mistakes it do it. So it is fine. Now after doing all those, we want to save the model, so we can always use this model in our future work. So we saved it as abdominal model final.h5, right? So after this we are creating a confession matrix, This is you should always show a confession matrix because it is very important, right? It is showing the accuracy, how it is predicted, because in a research paper or documentation presentation, as I always told, presentation is very important. So this is how you present it, right? Then it is this. After this part, the whole part is for researchers. So this is a confession matrix. Then what you are doing, recall, F1 score, this is all. You can see the code here, or the code will be provided in the description. You can always see that. That's fine. Open source codes. And then again creating a confession matrix that is much larger in shape, right? Then here we are doing a sensitivity, specificity, and IOU, intersection of union. So this is important in a research paper. You should give these three things at least in a research paper, that what was the output of sensitivity, specificity, and IOU, intersection of union. So this is the code for it, right? Most of you don't know what is the code, so depending on the formula we write the code here. Okay. Then send, spin, and that's all. So this was everything I did in this code. So a very simple code, a very basic code, a very basic beginner friendly code that can be your next project. And always it is open source in the description box. Click on the link and go through it. And you can always contact us through our email given in the description box. So that was this for the video, abdominal abnormalities classification using deep learning. Hope you enjoyed the video. Please subscribe to Sumit Institute channel, and like the video, share it with as many people as you can, and share your knowledge, gain more knowledge with us. We'll be making more and more videos. So thanks for watching. See you later. Bye bye.